Herd immunity and herd immunity threshold. So let's start off with herd immunity. What is it? This is how much of the population is immune to an infection. Moreover, it is an indirect way of protecting those who are susceptible. Maybe they're immunocompromised, they can't be vaccinated, etc. The list goes on. It is essentially reducing the risk of an infected person coming across another susceptible person. Right? That's all it is. And it is a way in which a herd immunity, we want a R0 or R of 1 or less than 1. Right then. Herd immunity threshold. This is the percent of the population that need to be immune for the infection to be unable to sustain itself and cause an outbreak. So we want R equals 1 or less than 1. But we're trying to find out what percent of the population we need to have that immunity to go and have that to cause the reduction in number of cases. Now the calculation is as follows. It uses the R0, and it's R0 minus 1 divided by R0, or 1 minus 1 divided by R0. So I'm going to be using the top one. I'm using an example here of COVID-19 because, as with before, R0 is for an entirely susceptible population, and it appears that everyone is susceptible for the COVID-19 outbreak or pandemic. So, a COVID-positive individual has an average of infecting 3.28 other susceptible people in an entirely susceptible population. So the R0 is 3.28. We'd want to go and take away 2.28 from this to make it at least become stable. But ideally we would want to reduce it even more by immunizing more. So then, the herd immunity threshold, we've got the calculation at the bottom. I'm using the top calculation from the calculations page. And we plug in the numbers. So it's 3.28 minus 1 divided by 3.28. This gives us 0.695. But what does this number mean? I'm going to round it up to 0.7. And the interpretation for this number is we're going to times it by 100 to make it a percent. 70% of the population need to be immune in order for the disease to become stable. Or, more than 70% of the population immunized will make COVID-19 unable to spread in the population. It will be unable to sustain itself because its R0 number will be less than 1. Now, I'd like to note at the end of this that the 3.28 actually comes from ECDC as an R0 number. Now, I'd also like to state, also based on a previous video, that R0 is also, it is largely based on behavioral changes also. So that's a dependent factor for the R0. And this number actually comes from Italy. And because the host population, i.e. humans, they're different in different, there'll be different cultural behaviors in different countries, as well as there's different governmental responses and timings to the coronavirus pandemic, mean that the R0 number will be largely different. It won't be hugely different, but it will be different in different areas. So I just want to, I don't want to state this as something that it is not. It is specifically for this case, and these numbers are changing all the time. Again, this is from April 2020. So now that is clear, that is herd immunity and herd immunity threshold.